Okay, here is chapter 7.4, the other trigonometric functions, pages 9 and 10. So we're going to talk about how to determine if a function is odd or even. You did this in Algebra 2, you did this in college algebra. It's the same with trig functions, it just feels a little different sometimes. So first things first, you're going to replace the x value with negative x. If your result is the same as the original function, then your function is even. If it's the opposite, then the function is odd. And if it's neither the same nor opposite, then it is neither. Neither, neither. Okay. So exercise 10, and we've done this before in the notes. We've got a point 10, negative 3 on the graph of f of x. If we know that f of x is even, that means the opposite input gives us the same output. So we know that negative 10, negative 3 is also on the graph. B, if the point 3,4 is on the graph and the function is odd, we know that the opposite input gives us the opposite output. Okay, so now we want to take a look at some of these functions that are a little more involved and determine whether or not they are even or odd. So we're going to start same way we did in college algebra. After we blow this up, by plugging in negative x. So cosine squared x means we're squaring the function. Same thing with sine. Okay. Cosine we know is an even function. So the cosine of negative x is the same as the cosine of x. Still have to square that. We know that sine is an odd function, so when we plug in negative x, we get the same thing as the opposite of the output. We're squaring these. Cosine x squared is cosine squared x minus, we got negative sine x squared, a negative times a negative gives us a positive. So we got minus sine squared x, which is exactly what we started with. F of negative x equals f of positive x. So we know that this function is even. B, we want to do the same thing. We're plugging in negative x. We get 2 times the sine of negative x times the cosine of negative x. We know that sine is odd, so the sine of negative x is the same as the sine of positive x. We know that cosine is even, so cosine negative x is the same as cosine of x. Pull that negative out front. We get negative 2 sine x cosine x, x, which is the negative of our f of x. So this function is odd. C, we got g of theta, so we're going to plug in negative theta. 1 plus cosecant negative theta. So cosecant is 1 over sine. I know that sine is odd, so cosecant is odd. So cosecant of negative theta is the same as negative cosecant of theta. I get 1 minus cosecant of theta. It's not exactly the same as g of theta or negative g of theta. So this is neither even nor odd. Neither. If you feel pretty good about that, you can probably skip over this next couple of examples. Example 12, we're going to do the same thing. I just wanted to reinforce this, or I was really tired and just created more examples. Who knows? So example 12, number 1. Darn it, where's my ABC? So if negative 2, negative 3 is on the graph and the graph is even, that means negative 2, positive 3 is also on the graph. If 3, negative 4 is on the graph and the graph is odd, then we know the negative input gives us the negative output. So back to the functions. I got f of negative t, secant squared negative t. Secant is 1 over cosine. We know that, here, let's rewrite this, secant of negative t squared. We know that the secant of negative t equals the secant of t because it's an even function, 1 over cosine. We get secant squared t minus 1, which is exactly what we started with. So we know this is even. F of negative x, we're plugging in negative x. Everywhere we had that x, I got negative x. Cosine is even, so the cosine of negative x is the same as the cosine of x. So we get the opposite of what we started with. So this function is odd. And 5 here, we get 2 plus the tangent of negative theta. Tangent is odd, so that's equal to the negative tangent of theta. 2 minus the tangent of theta. That's not the same as what we started with, nor is it the opposite, so this one is a neither. Okay. Part 3, we're going to talk about real quick here using a calculator. So the calculator will give you sine, cosine, and tangent, but not cosecant, secant, and cotangent, but we need to remember that these are the reciprocals. So 1 over sine is cosecant, 1 over cosine is secant, 1 over tangent is cotangent. And we will use that as we move into page 11. Make sure you grab your calculator.